objective, the first one is just a list. List the ways that you can get a sum of 5 on 2 dice. All right. So again, if we're looking at this dice chart, remember that they're arranged in kind of neat ways so that all the sums of 5 are right here. Okay. Notice that 4-1 is different than 1-4 and 3-2 counts differently than 2-3. Okay. So we're just listing those. And I didn't realize that this whole blank configuration that I have here for number 1 and 2 is confusing, but it is apparently. Sorry about that. I just allowed 2 blanks for the first one and then 1 blank for the second one. All right. Now the second one is where, again, we might want that formula sheet and figuring out what is the formula again for independent events. All right. Again, that's on here. It's one of kind of the major formulas we used. So please decide what the formula is for independent events. All right, so it's this one. 2 events are independent if the probability of their intersection equals the probability of one event times the probability of the other. And in number 2, the first event is rolling a sum of 5. Okay, so again, if it were me, I would have some dice charts available, and I like to actually circle these events and see what's going on. Okay, what's the probability of rolling a sum of 5? 4 out of 36. Okay. And then it says event B is rolling an even number on the second die, and that happens here, here, and here. All right. Or 6, 12, 18 out of 36. Some people would call that a half. That would be fine. Okay. And the probability of their intersection, because we're going to have to do this little test in a minute, of A intersect B. They intersect here and here. Okay, see where they're crossed or where things are double circled? How many ways is that? 2 out of 36. Okay. So to answer this question, determine whether the following events are independent or dependent. They're independent if this test is true. So in other words, if 236 equals 436 times 1836. Okay. So please use your fraction reducing skills, or if it were me, I'd use my calculator to figure out if those two sides are equal or not. And this is what I got. They're both equal to that decimal. Okay, so they are equal, but again, notice this is not a yes or no question. Okay, because if you answered yes, you're just saying, okay, they're independent or dependent. But I need you to pick one of those. So they would be independent. All right. Number 3. And 4, it says Jack, Andy, and Kim run for the same office in an election. Determine whether the indicated events are complementary, mutually exclusive but not complementary, or not mutually exclusive. Okay? If you remember on the end of this worksheet that I keep having us look at, we talked about the fact that, you know, here are the combinations of things that can happen. Okay? You can't be complementary without also being mutually exclusive. All right? And you can just be mutually exclusive, or this one doesn't have the choice of independent. But your choices here are really threefold. Complementary, which remember, again, that means they're also mutually exclusive. Or mutually exclusive but not complementary, that's another choice. Or not mutually exclusive. Those are the 3 things that we have to pick from. Okay. Now, we're not running numbers here because we don't have any numbers for Jack and Kim and Andy in terms of their election. So what we have to base this on are the definitions for mutually exclusive. Mutually exclusive events have no intersection, okay? Or complementary. Complementary events use the entire sample space and are mutually exclusive, okay? And those are the two things we want to think about. If we think about a sample space, I'm thinking about this. Jack, Kim, and Andy. Just going to put him down here, okay? And they are going against each other in an election, and we are assuming that no ties are possible. Okay, so decide what you think about event A, Jack wins the election, and event B, Kim wins the election, in terms of whether they're complementary, mutually exclusive but not complementary, or not mutually exclusive. Please decide. All right, so they definitely don't overlap. Jack and Kim can't win at the same time. Again, no ties are possible. And we didn't say anything about Andy. Okay, so these events are mutually exclusive, but not complementary. All right. For C and D, I'm going to make this sample space again. Jack, Kim, Andy. Okay. Read through there and see what you think about events C and D. Again, are they complementary? Are they mutually exclusive but not complementary? Or are they not mutually exclusive? Decide about number 4. So here, Andy can win the election is event A, and D is Jack or Kim win the election. Okay. Again, they're still not overlapping, but what I'm seeing is that everything's circled, everything's enclosed. So these events are complementary. And again, if they're complementary, they also have to be mutually exclusive by our little definition from back here. Okay. Number 5 goes back to independent or dependent, but again, it's not numerical. Like this one was numerical, this one's very sort of intuitive, this one's back to intuitive. Okay. Now remember again the definition of independent: events that do not affect each other. Okay. So we're trying to look at explaining whether these events are independent or not, selecting a king from a deck of cards, and then picking a king from the remaining deck of cards. All right. Decide what you think about in terms of those events being independent or dependent. So let me talk about this in 2 ways. The first way is, what's the probability of picking a king out of this deck the first time? 4 out of 52. Now, I know we don't have to actually calculate a number, but here's my point. If you don't replace the king, so you keep the king in your hand, and you want to pick another king, how many kings are there in the deck now? 3 out of how many? 51. So when I look at this, I say, hey, whatever we're doing there is changing the probability. So this event definitely had an effect on this event. Okay? The fact of the matter is really simple. Without replacement, if you don't replace the sock or the card or the marble or whatever it is always dependent.